I'm Mark Kemper with EMS, and this is the new Creaform HandySCAN Black 3D scanner. Now, Creaform claims this scanner has an accuracy of less than 1/1000th of an inch. So what I thought we would do today is put this scanner through some real-world tests and see just how accurate it is. All right, so let's get started, and we're going to do some measurements here. And what we're going to do is we're going to scan these artifacts. In this case, it's a ball bar. We're going to 3D scan it, and then we're going to measure it. Now, what this is this is a very precisely made ball bar. And right on here is a measurement that is created from a very accurate CMM. So once this thing is made, they measure these two spheres, and we have a point-to-point distance from the center of the sphere to this sphere, and that number is right here on this bar. So this is a calibrated, certified ball bar. Typically once a year you would send this back to the factory. They would recertify it, put a new number on here if need be, and send it back to you. So this is a good field test to be able to take out into the field and do a scan and just see how accurate you are. So as far as accuracy goes, you know, you see a lot of different manufacturers with some accuracy statements, but you don't necessarily know how they got to that number. So for example, you might see an accuracy statement, but what is the standard they follow to come up with that? Is it scanning a 1-inch gauge block and giving you an accuracy number? Is it just a point-to-point type measurement, or is it a 3D volumetric measurement? So you really need to look into any accuracy statement from any manufacturer and how did they get to that accuracy, what was the test they did. So for example, Creaform is a ISO 17025 accredited lab, which means they have certain standards they have to follow when they're doing their measurements or certifying anything. And what you get from Creaform when you buy any scanners, you get this calibration certificate, and if you look through this, you'll see how they came up with the numbers they came up with, okay? So a lot of this is a 3D volume measurement. So they're measuring it in a large volume, and typically, you know, ball bars like this in all different orientations are measured, and that's how they come up with this certificate. Now, for this test today, this isn't a gauge R&R, this isn't in an accredited lab or anything like that. This is more of a real-world example of what kind of accuracy I might be able to see. So I've got two ball bars set up here, one going across this way, flat, and the other one going back with some height to it. So, you know, this would imitate like a real part, okay? So we'll get some measurements in 3D space, and we'll see how accurate it is based on the numbers that are on the ball bar. So let's go ahead and get set up, and we'll go ahead and scan these two ball bars and see what kind of numbers we get. So we're not going to go into a lot of detail on how this scanner works. We have other videos that I would encourage you to watch that shows you all about the scanner. But what we do is on the smart panel on the back, we just click the button to start scanning, and away we go. Now I just have a targeted table or a targeted mat down here that has targets on it. That's purely for positioning for the system. So I'm going to go ahead and just scan this target. This sphere, and go ahead and scan this one, and then move over, scan this one. And you want to try to get, you know, as much of the sphere, you know, at least 1/3 of it, because we're going to fit some CAD geometry through it to do our measurement. So it's kind of like digital spray painting. You just move around and try to get the target, and then let's move up and get the back one here. And you can't overscan it. You can keep going over and over it till you get as much data as you want. Once you're done, hold down the button. That'll stop the scan. And then the last thing we're going to do is what's called Finalize. Now, if you look here, I've actually set up two clipping planes, one on the table and one on the wall, just so we don't get data that we don't want. It automatically just clips it off. And last thing I'll do is Finalize. And what Finalize does is, depending on what settings I've set here to do different things with the data once I'm done scanning, it'll go ahead and then perform that, and then we'll be done. Okay, so let's go ahead and hide those clipping planes. We don't need to see them. And what I want to do is I want to fit some geometry, some CAD geometry through those spheres. Now, this is the VX Element software that comes with the scanner, and you have some basic tools in here. So what I'm going to do is I'm going to come under Basic Entities. I'm going to create a sphere. I'm going to use the Connect Selection tool, basically anywhere where I pick, and it will create a sphere. And then let's go over here and create this one, and then the one in the front, and the one in the back. Okay, so now I have my 4 spheres, and now I'll go back and measure them. So I'm going to go point to point. I'm going to pick sphere 1 and measure to sphere 2, create that, and then sphere 3 to sphere 4 and create that. So I have my 2 measurements of those 2 ball bars, and what I've done is I just, to keep it simple, I created a little spreadsheet. I can quickly just plug in the numbers and see the difference. So ball bar 1, we have 25.5307 for a difference of 0.2 of 1 thousandths. And the other one we have 25.3752 for a difference of 0, at least out 4 places. So the manufacturer's stated accuracy is 0.0009, so just less than 1,000th of an inch, and we are well below those numbers. And again, we're not in a certified lab. We are in an office throwing a couple ball bars on a table and taking some measurements like you would expect to do in the real world. So it's incredible accuracy for a handheld device. If you think about it, you know, a few years ago, you would get these numbers from a CMM in a controlled environment with a big granite table, but everything had to be controlled. If you've used an ARM-based system, everything has to be fixtured and locked down and have it on a base and so forth. This is a completely handheld scanner. You pull out of a small case, plug it in, and scan away. So very, very impressive technology and the accuracy we can get. So very good accuracy. These ball bars are 25 inches apart. We've tried to set them up like a real part, and we've got just phenomenal numbers on this quick little kind of real world test.